look at some basic questions for chapter 5, learning effect of forces. Okay, one of the common questions that we have for learning effect is what the definition of moments of forces. Okay, the definition comes in various types, but they all have something in common, is they are actually asking for the definition of moments, and so there are certain keywords that students need to write down. Okay, for example, the most basic one, I will ask for definition for moments. Okay, definition of moments, and in the definition, remember, which is in the notes and the textbook, okay, you need to include words like product, okay, then after that the force, then followed by the last one is the perpendicular distance. Okay, please remember to write down the perpendicular distance. Okay, and perpendicular distance, usually the student need to couple it with like measure from where, from pivot, okay, to the line of action of the force. So you need these wordings in your answers. Okay, line of action of force. Okay, so you need these wordings in to make up for the definitions. The other way that the question can ask is asking for the same thing, but they ask it in, maybe they ask it for like how force, moments of the force of torque is calculated. It's the same answer that students are required to give to the marker. Okay, so please take note of it. And after that, we have the basic questions. There are other type of basic questions which involve moments also, but now we involve the calculations of moments, okay, which is the formula. Okay, the most basic calculation is what you see in question 4. Okay, question 4. Okay, question 4, calculation wise, will be require the student to apply the formula, substitute the magnitude for force and the correct answer for distance, perpendicular distance. So most of the common problems students have usually is identifying the relevant or the correct perpendicular distance. Same thing as I mentioned in the video, in the lesson for moments. Okay, remember, how do I get the perpendicular distance? Okay, I'll draw the line of action. Okay, for the force, what I do is I will copy and paste it to the pivot. Okay, so this copy and paste exactly the same line, so this will be step 2. Okay, so step 2, after that, after step 3 would be I want the shortest distance between these two lines. The shortest distance between two lines would be the one that is here, the shortest distance. This will be your step 3. Okay, step 3, okay, and this will give you the perpendicular distance for the 3 Newton here. Okay, remember the 3 steps. Okay, copy, identifying the line of action of the force. Then after that, duplicate this line to the pivot, and followed by finding the shortest distance between this particular line. Okay, so these are the things that we are looking out for. And once you have it, you actually have what we call the D perpendicular distance. Okay, and once you identify the correct perpendicular distance, remember there are a few choices. Usually the questions will allow, will have some distractor like the 5 newtons here, and 5 meter here, and 3 meters. Sometimes I even give you the opposite distance here. Okay, so the opposite. So the student need to choose out of these 3. There's a 30% chance of choosing there's a 30% chance. So the students need to know exactly how to identify perpendicular distance and to choose, and thus choosing the correct distance, perpendicular distance always. Okay, so once you identify the distance, you identify the forces. Okay, so what you do now is you actually substitute it into the equations. Okay, once you substitute into the equation, the next hurdle will come. Okay, the first problem, the first pitfall is identifying the correct perpendicular distance. The second problem students will have is actually the SI units. Okay, the SI unit of the relevant components. Okay, remember, for moments, the final unit for moment is Newton meter. So what students need to look out for is to make sure that the force is in Newton, then followed by the distance is in meter. Okay, the distance has to be in meter. Okay, so once you make sure these 2 hurdles are checked, your answer will always be correct. Okay, so for this answer, it will be a simple 3 times 4, it will be 12 Newton meter. Okay, so please take note, these are what we call simple, the basic applications of moments. Okay, the other section of this topic will be the principle of moments. Okay, the basic question for principle of moment is actually same thing, which is definition. But the definition is when we talk about principle of moments. Okay, some students tend to be confused over the basic definition of moments. So there is actually 2 definitions we are looking out for. One is the definition of moments, and the other one is principle of moments. Okay, this is what we call they are quite similar in the sense that when I apply moments at different situations and they are in equilibrium, and I actually equate these two type of moments, primarily clockwise and anti-clockwise, at the equilibrium situations, I am actually using principles of moments. So when you talk about principle of moments, the key things we are looking out for is the total clockwise moments and the total anti-clockwise moments. So these are the two things that must be included in the definition, and followed by they are all measured about the same pivoting point. Okay, same pivot, and lastly, these two moments, they are always equal. So this is what we call equilibrium. Okay, so one of the common things that we have in the definition of moments, the keywords that we have is students. We actually make sure the students need to know whether it is in equilibriums, whether the moments are equal, and whether does the students know that all the moments clockwise and anti-clockwise are actually measured from the same pivot here. Okay, so do take note of these certain keywords when we look asking out for definition. Okay, and also to make sure you define the correct definition, or you give the correct definition. Okay. Now for question 7, okay, is actually similar to question 3. Question 4, sorry. But what we do now is we actually apply question 4 at different forces at different locations to give rise to different type of moments. And after that, since the question says is in equilibrium, so what does this mean? It actually means that the total, okay, clockwise moments will be equal to the total anti-clockwise moments, and this principle is what we call the principle of moments. Okay, rotational equilibrium. So to do that, you need to identify the moments of each forces. Okay, so for the 18 Newton, which is on the right side of the beam, okay, so if you pull down the 18 Newton, okay, right down on the right side, you'll find that the rod will actually rotate clockwise. So 18 Newton will actually give rise to a clockwise moment. Okay, as for the force on the left side, okay, when I pull down on the left side, I actually have a anti-clockwise moments. Okay, so I actually have an anti-clockwise moment, okay, for my force. Okay, so this will be anti-clockwise moment. Okay, so these are the two forces that we're looking for, or the two moments we are looking out for. Okay, so how do we calculate the clockwise moment, okay, of the due to the 18 Newton force? So this is the same thing. I identify the force, I identify the perpendicular distance first, same as question 4. So same thing, perpendicular distance, I will get it from the line of action. Same thing, step 1. After that, I'll copy to the pivot here to give me the perpendicular distance for the 18. Okay, this is the perpendicular distance for the 18 Newton. Remember, it's measured from the force of the line of action of the force to the pivot itself. So the distance between these two will give me the perpendicular distance of the due to the 18 Newton measured from the pivot. And together with these two numbers, the 18 and 18 Newton, I actually have the clockwise moment already. Okay, which is here. Okay, so this will be the clockwise moments. So how do I look at the anti-clockwise moment? So similarly, what I do is I just repeat question 4, or I repeat the process for the anti-clockwise moment again. So, but now I do it for the force F. Okay, so force F, this is the force I'm looking out for. The perpendicular distance, what do I do is I need the step 1, I need the line of action. What I do is I copy and paste to the pivot here. Okay, this will be my step 2. Once I have it, I will find the perpendicular distance, the shortest distance between these two lines, and this will be what we call the perpendicular distance for my D force. Okay, I label it as DF. Okay, one of the things that students need to be careful is that DF, okay, is actually not the whole ruler. Okay, it's not even one of the clues that's given in the question. So the question gives us 5 meter. The question gives us 2 meter. But remember, DF is measured from the pivot to the line of action of the force. So it's actually here. So you find that using a simple math, you find that DF is actually 3 meter. Okay, because 2 meter and 3 meter and 2 meter will make up the total length on the left side of the ruler, which is 5 meter. Okay, so this is where students need to really know how to identify the D perpendicular. Because D perpendicular, sometimes the question will give, sometimes the question doesn't give explicitly, so the students need to know where to work out. Okay, so if you know the D perpendicular is 3 meter, you know the force is F, you will have the components for your anti-clockwise movement here, okay, which is F times 3 meter. Okay, once you have it, the basic things that you look out for is you use principle of moments, whereby the clockwise movement is equal to the anti-clockwise movement. So this will be what we call the principle of moments. Okay, so once you have the equations, you will let your algebra take over and you solve for the unknown F. Okay, which will be 90 divided by 30, 90 divided by 3 will give you a straight answer of 30. So force will be F, magnitude of the force will be 30 Newton here, using principle of moments. Okay, so from this question, you will know that it is actually important to see the correct force, correct perpendicular distance, especially perpendicular distance. Okay, but do remember, do not memorize the working by heart. So let's say if student memorize the working, you will find that the working will be duplicate here, and you find that the same working here will be wrong. Okay, because for these questions, okay, the students will actually need to identify the correct perpendicular distance, okay, for each of the force. Okay, so each of the force, they will need to identify the correct perpendicular distance, correct perpendicular distance, and correct perpendicular distance before the student can actually use this principle of moments. So the first step, okay, identify the correct relevant perpendicular distance. Okay, before I go ahead to solve this, okay, students, please spend some time to solve this question first. Okay, I'll come back to the solution in my next video. Okay, so in the meantime, okay, please spend some time to try to solve the answer yourself. Okay.